Section 8.4, Graphing Quadratic Functions. A quadratic function is a parabola, and that is, on a graph, it is a U-shape, either right side up or upside down. And in our parabola, we have the very minimum point here on the y-axis, or maximum if it's facing this way, is our vertex. The line that goes right through the center of that vertex, splitting the parabola evenly in half, is called the axis of symmetry. When the parabola opens upward, as in this parabola, opening upward, that means its vertex is a minimum value for y. When the parabola opens downward, as in this parabola, the vertex has a maximum value for y. Example, to graph the function x squared minus 2x plus 4, we need to first find the vertex. To find the vertex, we are looking for the coordinates of that point of the vertex, which is xy coordinates. To find the x part, we have an equation that x equals negative b over 2. A. Remember standard form of an equation. B is the middle term, the coefficient, which is negative 2. So now we have the x value of the coordinate equals negative 2 over 2 times a, which is 1. Now be careful here, because the formula has a negative and b is negative. A negative and a negative give us a positive 2 over 2, which equals 1. So now that we found the x value of the coordinates, we need to find the y value of the coordinates. To find y, we take our original equation, x squared minus 2x plus 4, and the f of x represents y, so we're just going to replace that with y. And now we're going to take the x we just found, 1, and replace it in our equation. 1 squared minus 2 times 1 plus 4 gives us 1 minus 2 plus 4, which equals 3. So the vertex has coordinates 1, 3. Now on a graph, we can plot that coordinate 1, 3. X is 1, y is 3. The vertex sits right here. Now we need to determine, is our vertex going to open up or is it going to open down? And we can tell that by looking at the very first term. If our leading term is positive, it opens up. If it is negative, it opens down. So we know that our parabola is going to be coming this way. So to graph that, we want to find more points on our parabola. So we're going to use our XY table. And we're going to pick values for X and plug them in. Make sure you pick some negatives, 0, and some positives. Our original equation was y equals x squared minus 2x plus 4. If x is negative 2, we have y equals negative 2 squared minus 2 times negative 2 plus 4, which gives us 4 plus 4 plus 4. So y equals 12. And we can plot that coordinate. Now that's going to be off my graph a little bit. So let's move that over. So I know that the point negative 2, 12 will be someplace way up on top. Now let's try 0. If x is 0, we end up with 0 minus 0 plus 4, which is 4. There's another set of coordinates we can plot, and that would be x is 0, y is 4, right here. So I can see this side of my parabola is coming up this way. Now I need to find the other side, and I can do that by using the positive 2. That will give me 4 minus 4 plus 4, which equals 4. I can plot that set of coordinates. 2, y is 4, right here. So I know the other side is coming up this way. Now we need to determine the domain. The domain is the set of all x values in all of our coordinates. Every coordinate for every point has x values. And as our graph opens up wider and wider, our domain is going to cover all x values and be the set of negative infinity, positive infinity. The range, however, is all the y values in every set of coordinates. So our range can only go as low or as high as our y-axis. And in this case, that is at 4. And it continues to go up and up on both sides. So our range will be 4, positive infinity. And I use the bracket here because it includes the 4.